We pull up a website, click play, and expect the data to be there. We interact with the internet operating on a specific illusion that global cloud platforms are perfectly stable and always online. The engineering reality is much harsher. Hardware degrades, backhoe operators cut through fiber optic cables, regional power grids collapse. Massive hardware failures are certain. Even major cloud providers drop offline. When an entire cloud region goes down, the blast radius is immediate. API calls time out, authentication databases lock up, and millions of users are suddenly staring at error screens. For a global platform, a 5-minute total blackout means ad revenue halts, subscription signups bounce, and millions of dollars evaporate into the dark. Pinning an entire digital infrastructure to one geographic spot guarantees that when that specific location drops, the whole business goes down with it. Netflix serves millions of concurrent video streams to users across the globe at any given second. A localized outage threatens massive portions of that active audience. Engineers often duplicate hardware within the same city, known as multi-availability zone redundancy. This keeps you safe if a single building loses power. But if an entire region goes offline from a massive network error or natural disaster, those localized backups die too. So if physical data centers will inevitably vanish without warning, how does a global streaming service keep the movie playing? You stop trusting the hardware. Netflix engineers build their ecosystem on a single governing assumption. Failure is happening right now. Surviving a catastrophic outage requires accepting that you cannot fix the servers once they break. The rescue operation has to be fully constructed before the emergency ever begins. This relies on an active-active architecture. Rather than parking all their resources in one centralized hub, Netflix distributes their systems across multiple independent global regions, all processing data at full capacity. In this model, there is no primary server. There are no idle, cold backups waiting to be booted up. Every single region is engineered with enough overhead to absorb the traffic of the others at a moment's notice. To make these separate physical locations operate as a single system, Netflix relies on continuous data replication. Playback histories, recommendation algorithms, and account metadata are constantly synchronized and copied across the global network in real time. By the time a server rack actually fails, the surviving regions already hold the exact data required to instantly take over the load. Let's track the exact sequence of events when a massive hub, like the US East region, suffers a sudden total failure. First, automated monitoring metrics detect the drop. Latency spikes, error rates climb, and internal tripwires trigger an immediate alert. Global acceleration and routing protocols instantly intervene. They block new connections to the compromised zone and redirect all active incoming traffic toward the healthy servers in other regions. To stop stalled requests or corrupt logic from cascading through the rest of the network, the failing region is completely amputated from the global infrastructure. The remaining active regions shoulder the global load entirely. They process the redirected traffic, while the failed region is isolated, diagnosed, repaired, and slowly brought back online. This massive geographical pivot takes millions of users and shifts them across continents. It executes fully automatically, resolving in a matter of minutes, without a single human engineer pressing a button. Building automated safety nets requires DevOps teams to meticulously configure identical server environments and perfectly script the rules of evacuation. But creating the logic on paper guarantees nothing. Engineers prove the automation works by intentionally attacking their own production systems, a rigorous practice known as chaos engineering. By terminating active servers, choking network traffic, and simulating latency during peak viewing hours, DevOps teams force the automated failover to react under intense, realistic stress. Subjecting an ecosystem to constant engineered sabotage is the only way to prove it can survive an actual disaster. While global acceleration networks divert massive datasets across oceans and automated pipelines isolate dead server farms, a very different reality plays out in the living room. A user on their couch clicks a title. The app hesitates for half a second. A buffering wheel spins briefly, and then it plays. Millions of dollars of critical infrastructure just disappeared from the internet, and the person watching the movie didn't even notice. Trying to construct a perfect, unbreakable server infrastructure is a losing battle. The hardware will eventually fail. Surviving those failures requires abandoning the single region model. It requires active-active distribution across multiple zones, continuous real-time data replication, and ruthlessly tested automated failover. If your system operations rely on a single geographic point, you are banking on luck. True operational stability comes from letting the servers fall and engineering a network that simply routes around the damage.